Hi, I'm Gwen, and this is a talk about cross-platform libraries and tooling. So this is partially inspired by the work to port Swift Foundation and its build tooling to Windows. However, I've tried to make this all generally accessible. So my main goal here is to point out areas that, if thought about early on, can make porting your application down the line fun and exciting. So let's start with my favorite thing, paths and file systems. On Unix, it's relatively easy to parse paths. On Windows, it's relatively easy to get paths very wrong. Quick quiz, which of those are valid Windows paths? Trick question, all of them. Mostly. The ones with forward slashes may or may not be valid depending on the API and depending on the path parser that they go through. Check out that link for details about exactly what all of those are. So eventually you will have to do your own path parsing. And so when you do, read before, defer to system APIs when possible, or provide abstractions to be able to get around these things. The fewer hard-code assumptions about paths that I see day to day, the happier I am. Similarly, try to avoid string matching paths when testing. So this is for multiple reasons, not just for, say, matching forward slashes and backslashes, but system directories on different systems are in different places. And say matching against /temp will make your tests fail on Android and Windows. All right, what about building and testing? Well, the big one here is just keep cross-compiling in mind throughout. Use a nice cross-platform build system. I like CMake. And while you're doing this, be very, very careful about Unix commands. Android, for example, is missing a lot of the Unix commands that you might expect it to have. No, I'm ahead. On the other hand, MSys does work, but it is its own minefield of gotchas, especially around Unicode. Going a little bit lower level, be very careful about designing around linker formats. Things like symbol placement and thread local storage are different on different platforms, and if your underlying linker format doesn't support something, it can be very hard to support that in your application level. What about existing libraries? Well, if you're doing existing libraries, a system library, you're going to have to call system APIs, and that means you get to use Unicode. And so UTF-8 is pretty standard now, well, except on Windows, which uses UTF-16, and Darwin, which uses both. So there are kind of two approaches to handling this. You can define a platform-specific type that's different sizes on different platforms, and this is okay until you have to do any sort of string manipulation. Then you have to know what's actually inside. So then the conventional wisdom is to convert everything to a single encoding, usually UTF-8, and then convert back on the edges. And this is something that both Swift and LLVM actually do. This is also handy when you are integrating into existing code base because you can reuse the existing Unicode applications. And you know what they say about Unicode implementations, reduce, reuse, and recycle. And another one is you have to be okay with things just sometimes not making sense. For example, Foundation exposes POSIX permissions, and on Windows, you grit your teeth and you do your best to match the exposed semantics, and then you move on. POSIX APIs, while implementing, are a handy tool to have. However, they are, again, more caveats. Windows does support many POSIX APIs with limitations. For example, _open doesn't allow you to pass some of the file sharing permissions that you might actually want to do. And again, Unicode support, a little bit iffy. Android, conversely, doesn't support many of the APIs that you might expect to have. This often depends on API level. For example, Get IF adders wasn't implemented until API level 24, and this made some of the networking implementations a little bit more difficult than maybe they had to be. Finally, a handy trick to have is to re-implement your old target's API set with your new target. So, for example, implementing RealPath or LStat on Windows, or who knows, one day implementing create file W on Linux. And even if your implementations are a little bit half-baked and only support exactly what you need, this is a handy way to reduce the number of code paths that you have overall. So thank you very much for listening, and I hope you go listen to these things and make someone porting your application happy.